everyone, welcome to another episode of FreeRTOS On Demand video, where we take the topics requested by you, members of the FreeRTOS community, and talk about them. I'm your host, Rashid Talukder. In today's episode, we're going to be touching really quickly about two things. Number one, we just released FreeRTOS LTS. LTS stands for long-term support, and what it means for you is that we're going to be providing a stable set of APIs for the libraries that are marked as LTS for 2 years and continually provide critical bug fixes and security patches. So you can trust that the APIs will remain the same and not affect your application that you've written, and ease the burden of maintenance over time for you. In addition to that, we also announced a preview of our cellular LTE-M interface library. And we worked with some of our cellular vendors, such as CR Wireless, MuBlocks, and also Quectel, to work with some of their modules using this library and providing some easy out-of-the-box reference integrations for you to look at and be able to incorporate into your applications. So please make sure to check that out if you've got a cellular module, and let us know with some feedback what you think of it, where we can improve. Send us pull requests if you've got some fixes or some any additional features that you think is worth us merging. So with those two quick updates out of the way, I wanted to get into the meat of our presentation today. Specifically, we've got a little technical demo for you today. I mentioned last time about our core prefix libraries, about their composability, lack of dependencies, ease of use because of MISR compliance, and a host of other features in these new core libraries. So today I wanted to have one of our engineers actually give you a quick technical demonstration of how to use this library, and hopefully it gives some confidence in some of the features that we talked about, but also if you've got existing applications, to be able to quickly migrate to the new coreMQTT libraries. So just kind of give you some highlights there. So I'm really excited to have none other than Gaurav Aggarwal. I'm sure many of you have seen him within the community forums, within GitHubs. He's always responding to so many questions. We're incredibly grateful to have him and his talents. And grateful to have him here. So I'm proud to introduce Gaurav Aggarwal. Gaurav, thank you for joining us today.
Thank you, Rashid, for the invitation. Hello, everyone. I'm Gaurav, and I am an engineer on the FreeRTOS team. Today, I'm here to show you how to use our core MQTT library in your application to talk to an MQTT broker, such as AWS IoT. Core MQTT library is a client implementation of the MQTT protocol, which is optimized for resource-constrained microcontrollers. Core MQTT library is a standalone consumable, and what it means is that it can be used with any underlying TLS and TCP stack. For today's demo, I'm going to use a DevKit C platform from Expressive and an Expressive software ESP-IDF. ESP-IDF has a component named ESP-TLS, which enables TLS over TCP communication. And we are going to use ESP-TLS to establish the TLS connection with our MQTT broker, and then use core MQTT to establish MQTT connection on top of that.
And before we dive a little bit further, Gaurav, I just wanted to highlight to our viewers that while this demonstration uses the ESP IDF, which is Expressive's toolchain, the core MQTT library is agnostic of that. You could actually apply it to any other platform that you have. Just in this particular case, we are using the ESP IDF, which is FreeRTOS with SMP support for their Extensa dual core Extensa processors. So that's just wanted to clarify that for anyone else. It can apply to any other hardware platform that you might be using. Go ahead, Gaurav.
Yeah, it can apply to any other hardware platform or any TLS and TCP stack. That's what we're trying to show here. So to start with, our core MQTT library expects an implementation of a very simple receive and send transport interface. And here, as you can see, I'm implementing this transport interface using ESP-TLS API. And all I do in this implementation is call ESP-TLS API and handle some of the non-fatal retriable errors so that those are not treated as errors by the core MQTT library. This is the implementation of the receive function, and this is the implementation of the send function. Once we have the implementation of this transport interface, we can actually move on to writing the MQTT application. And we're writing a very simple application here, which subscribes to a topic and then publishes a message on the same topic. Since the application is subscribed to the same topic, it receives the same message back from the MQTT broker.
Right.
So this function here shows the skeleton of the application. The very first thing we are doing here is we are establishing a TLS connection with the MQTT broker. And as you can see, I'm using ESP TLS APIs to establish this TLS connection. Also, we are using exponential backoff with jitter while retrying in case of failures. It is a best practice to always use exponential backoff with jitter to ensure that the load on our backend services remains even. To know more about exponential backoff with jitter, you can read an article from one of our senior principal engineer named Mark Brooker. And since this exponential backoff with jitter is such an important and useful algorithm, its implementation is provided in a separate Git repository and it can be used by any application. Once we have established this TLS connection, we move on to establishing the MQTT connection, and we are using MQTT Connect API from the core MQTT library for that. As you can see, we are providing our implementation of send and receive interface here to the core MQTT library. Once we have the MQTT connection established, we move on to subscribing to the topic, and we use MQTT subscribe API from the core MQTT library. Again, you can see here also we are using exponential backoff with jitter while retrying in case of subscription failures. After that, we go on to and publish a message on this topic using MQTT publish API. And then we wait to receive the same message back from the broker. After
Right.
we
Because we're on the same topic.
Yeah, after we receive the same message from the broker, we go ahead and like unsubscribe from that topic and then disconnect using MQTT disconnect API, and then we close the TLS connection using the ESP TLS API, which actually completes the demo. And I'm going to show
Cool.
you a sample run of this. So first I am going to build this demo. To save some time here, I've already built this. And then I'm going to flash and run this.
Yeah, and while it's being flashed, I want to point out that the the ESP IDF. I mean, we're using the ESP TLS, which is embed TLS underneath, but you could also use Wolf SSL, or anything else. Again, dependency free.
Right, yeah. I mean, by default, ESP-TLS uses embed TLS, but it can be configured to use our Wolf SSL as well. So here it's running, and as we can see in the logs, we first established a TLS connection to our broker, and then we established the MQTT connection. After which we subscribed on this topic, and then we published a message hello world on the same topic. Since we were subscribed on the same topic, we received the same message hello world back from the broker, and then we unsubscribed from the topic and disconnected both MQTT and TLS connection, which completed the demo.
Nice. Very cool. Very cool. So really quick, Gaurav. I mean, thank you so much for that demonstration. Um, I think I think I just want to hone in again on the real benefits here. Is just the ease of use and the composabilities. I mean, the API calls that need to be made. I mean, they're very clear, straightforward. And again, like the composability, we're in this case we're using ESP-IDF, ESP-TLS, like Gaurav mentioned, which is just embed TLS underneath. Um, yeah, I think you did a great job with this demo, and hopefully members of the community really pick up and go the next mile with what we want to see with them using these core libraries.
Yeah, I hope so too.
Cool. Well, thank you so much, Gaurav, for joining us today. And hopefully we'll get to see you again sometime soon.
Thank you very much. Thank you, Rashid, for inviting me.
Yeah, of course. So that concludes our second episode. And before we let you go, please make sure to hit the like button, the subscribe button, and also the notification bell. If you look down below in the description, you'll find a link to Mark Booker's blog about exponential backoff algorithms and jitter. And also, you'll find a link to the FreeRTOS forums, specifically the post in the community media category, so that you can go ahead and post your comments and give us feedback in there and have a much richer discussion than just within the YouTube comments. So we've disabled the comments for that reason. Go on to FreeRTOS community forums on forums.freertos.org and post your comments and have discussions in there. Looking forward to next time. Thank you so much. Take care.